Jan Feb 2024 with an attempt. So we'll be discussing the solution that was given that we have and see where you went wrong or if you're right. We'll just assume that yeah, okay, cool. So this one says this question paper is based on a simplified scenario where records of patients admitted to a hospital with infections are kept. A main client would be responsible for gathering all the required information from the user, where the recording is based on a central container or list of patients' records, which is written to a file when the application is closed and read in from file when the application is started. Okay. Patients who have a patient number are considered to be of two types: health workers, where it needs to be known where the patient works, and non-health workers, in which case the testing site needs to be known. Each patient record also has an object indicating the infection that the patient has, assuming that each patient has only one infection. An infection which has an infection code could be viral with a flag indicating whether there's an antiviral that is effective against it, or bacterial with an indication of an antibiotic which is effective against it. Question number one, you know the drill. Create a YAML class diagram to express the scenario described above, taking the design patterns into consideration in the design. You should include the necessary classes, class attributes, class operations, and class relationships to make it clear you understand how data will be managed and passed between classes. Include the client class to be used. This could be you in the next couple of weeks. Okay, so before we jump into the solution that the person who asked this presented, let's just discuss the question, see that we understand what's happening, what to expect, and the kind of solution that we can expect from this kind of a diagram. And so just reading this question, we always try to identify entities. I mean, the first thing you always try and do is to identify the classes that you need, right? Or the entities. And these classes could be like your entities, like your objects. It could be containers, like your list. It is usually the serialization. Usually that's like reading or writing to a file. These are like the common things that you do. You identify inheritance. You also can include factory method design pattern if you want, if there's inheritance. These are like all the ideas that come to mind whenever you're trying to do your solution. And usually all your diagrams, these are the things that you usually just need to cover in terms of your diagram. And we've always said that whenever you're doing your diagram, understand why you're doing whatever you're doing. There has to be a concept, a principle that you're following that says, if you see this, then do this. Don't just guess classes and diagrams and arrows without really understanding what you're trying to do and why you're doing it. So coming back to this, so we know that we've got patient records, fine, no problem. A main client will be responsible for gathering all the required information from the user, fine, where the recording is based on a central container or list of patients. So already we can see here that we've got a list of patients. Things like a central container normally hint you towards singleton design pattern, because whenever you want to centralize data storage, you go with the singleton design pattern, which then says you've got only one instance available. So anything being central, or whenever you see something towards or hinting towards centralization, that also hints you towards the singleton design pattern. Right, or a list of records, right, which is written to a file. We do know that when you write to a file, that's serialization, which means you're going to write to a file. When the application is closed and read in from file, again, that's deserialization, which means if we apply the serializer pattern, we've got two classes now, one that writes to a file, one that reads from a file. We discussed this in our last lesson. I think the video is not yet up, but once it is, you might want to go and catch up there, because we discussed basically the serializer design pattern. We've done so also in the past. Right, so patients who have a patient number, the moment you see an attribute, that also tells you it's a class, which means if you've got a patient number, it has to live within an object. That means you've got a class that should represent a patient, right? Are considered to be of two types. Again, once you've established that your patient is a class, usually we always expect inheritance, like in most cases, inheritance. And you know it's inheritance when you start dealing with types of something that has been established to be a class. So if you've established that patient number means a patient is a class, then health workers and non-health workers then begin, to become your subclasses that then inherit from your patient class. And to further emphasize that health workers should then become a class is because you've got an attribute. Because if it's a health worker, it needs to be known where the patient works, right? That's an address or a location. That's an attribute, which means it has to live within a class. And non-health workers, in which case you want to store the testing site. So these then become your attributes within these classes. Already you can start to see the picture of having a patient and health workers, non-health workers there. Each patient record also has an object indicating the infection that the patient has, assuming that each patient only has one infection. Okay, so we have this as part of a patient record. So we now have a patient as a class with a patient number, and a patient can be this. Patients with a patient number are considered to be of two types. So we've got this. And then a patient record also has an infection, which assuming that each patient is only one, an infection which has an infection code. Again, this tells you this is a class because we've got an attribute. An attribute has to live within a class. So already I see that I've got an infection, which is an attribute, which could be viral, with a flag indicating whether there's an antiviral that is effective against it, or bacterial with an indication of an antibiotic which is effective against it. So again, if an infection is an infection code, then viral and bacteria then become types of infections because a viral infection would have a flag that says, is there an antiviral or isn't there? Or bacteria, which has an attribute that says antibiotic. So you can see just by reading through your paragraph, you start to pick up like classes and you start to come up with a sketch of what's going on. All right, sorry about that. So what I was saying is from here, from reading this, the next stage that I normally recommend is draw a sketch, just to show what classes you need and the kind of relationships between those classes. Put your inheritance, put this, put that. All right, so I'm going to leave it here and go straight to the solution that you attempted, and then we can discuss it further. Now, this is what you did. And let's see what's going. There's a lot going on here. There is really a lot going on here. So I'm going to break it down and just follow the same logic that we see from the question. And I'm going to start off by with a patient and then health workers. So we can say we start here with a patient record. You call this an individual record. That is a patient number. Right now, I'm not going to go into the details, just like the structure of the classes involved. And then you rightly had your inheritance there, and then you've got your health workers and non-health workers with your area of work. That's where you work, and then you've got your testing site. So that looks fine, right? And then we learned that these patient records should be stored in a list or a container of some sort. So you went with patient records, which is now representing your container, which is going to store your records. And for your container, you just went with inheriting from a queue list. Now, I get it, but a queue list is of type patient records, whereas your class is of type individual record. Now, that's a discrepancy right there, because your type, whatever your list type is, it's the things that you want to store in that list. So that should match that. Otherwise, there's then misalignment, because you've got a list of patient records, but your classes are individual records. Then how do you then store these things in that list? Right? There's a mismatch. So that's one thing. But the idea, though, I get it. So you've got your patient records there. Now, a patient has an infection, right? So let's just go to the infection. So you say, yeah, so infection is a class with a code, and it can be viral or bacterial with a flag that says, is there an antiviral or is there an antibiotic? And again, inheritance. Perfect. Now, an infection is an attribute to your patient record, which means an infection instance lives within a patient record, which means for a patient record, we need to know what type of infection it is. So inside your individual record, we want to see an infection. So that you put aggregation there, which is correct. The question then becomes, where is it? Where is it here? I don't see the actual infection attribute inside your class, because rightly it's aggregation, because you're saying within an individual record, I've got an infection. Yes, but where is it? You didn't put it here, which then violates why you've got this line, because this line simply means there's an infection here. But otherwise, I like that. And then with this part, that generally just illustrates your classes, like your records, and your infections. Perfect. Now, we do know that we want to write our patient records to a file and read from a file, in which case we apply the serializer design pattern. And the serializer pattern simply says, what is it that you want to write or read? From that object, you just create two classes, one that writes, one that reads, and then they both have an association relationship with your object. So that is correct. You did association there. Let me just be consistent. You went with association, which is fine. And you made a class that writes, one that reads your patient records. So in terms of the structure of your classes, that's looking good. And then applying design patterns, you went with factory, because whenever you see inheritance, that's an opportunity to apply factory. So because you've got inheritance here, you can apply factory. Because you've got inheritance here, you can apply factory. Now, these are additional things that you have to do. But this stage that we've reached is exactly where you want to be, where you've got your classes, you've got your inheritance, your basic relationships are in, and all the classes that you need are there. Perfect. Already you've applied serializer here, which is something that we always do by default if you read or write. Now, the next stage is then applying factory. So here you've got your record factory, you've got your uses relationship, which is rightly association, and you've got your creates relationship that go that go there. And you've got another factory, infection factory, that uses that and that creates these, and that's your factory. Perfect. So you applied your factory correctly. That's fine. That's factory. And then you've got your client. Now, your client is the one that is responsible for using all of these classes. So within your client, you're going to keep under private maybe a list of patients. So yes, you're going to have an aggregation relationship between your patient, your client, and your patient records. So because you would expect to have an instance of this within your client under private. And your client is going to use your writer to write to a file. It's going to use your reader to read from a file. And rightly so, you said, therefore my client knows about that, knows about that. Your client is going to use your factory to create infections, and it's going to use another factory to create your records. And that's it. I think that's pretty much good. That's pretty much enough. So in terms of your classes, I think you did a very good job putting all your classes together and having the right relationships together. And you can see there's a lot going on, but if you break it down, it becomes easier, because it's difficult to just think of this diagram in one shot, like just this is the diagram. No, we do it one step at a time. So I really like the classes that you've got and all the relationships. Now, the next stage, so I would expect you, before you write your final answer in your actual answer book, to at least get to this stage just with your classes, without going into the details of what's where. like the actual attributes, which are like these things, at least get to this stage in your sketch. Now, the next stage that you wanna, once you get to this stage, you know exactly how your diagram looks, which means you know how you're gonna draw it, whether you're gonna do like a landscape diagram in your like A4 paper, at least you know how it's gonna look like. The next stage now is what are you required to include in your classes? So already by getting here, you have covered your classes, you have covered your relationships, right? Now, this question varies from one paper to another in terms of what they need. Sometimes they don't need attributes. Sometimes they do need attributes. Sometimes they don't need functions. And sometimes they do need functions. But in this case, they wanted class attributes and class operations. In other words, the functions that are necessary to highlight or indicate how the functionality within your classes. So we use the next stage. You do your attributes, and then you do your functions. I think that was all straight clear that so your class attributes now, these are now your patient number. That's where we need to see infection within your class here, so that to show that you've got an infection. Otherwise, you've got your patient number. I don't know how the format they want you to use, but the right way of doing an attribute is to do the name of the attribute. So you'd go, it's private, it's patient number, for instance, and it's a QString, like that. That's like the full way of doing your attributes. Like what the access modifier, is it private, public, protected, and then what type is it, which is then QString. But I see in this case you just went with patient number, which is fine, but let's just do it in full because I don't know exactly how they want you to write those attributes. So you do your patient number there. I don't see, I see your area of work, which then should be a QString, testing site a QString, is a Boolean, is antibiotic Boolean. So put those types in, that's fine. Then in terms of your serialization, here we do need the functions always, because we need to see what your read function is doing and what your write function is doing. I think we spoke about these two in detail in our previous lesson, but your read function should return the thing that it's creating. So which means your read function here takes a path, which is where to read, but it should also return what it's reading, because it should create the patient records. So this would then return your patient records instance, which is this guy. Your writer should, in this case, it receives a path, which is where it's writing, and it also receives your queue list of patient records, which is also okay. So I think your write function is fine. But otherwise, I think it's a very good attempt at this question. It's one of those tricky ones that gave students headaches. And I want you to also realize that last year, some students walked into the exam and were met by this question, and they had to figure this out. And this was not one of those easy questions. And just imagine you start your exam, you download your paper, you open it, and first question, 33 marks. It just means that it's important and it's not something you can overlook. And you don't want to fail to do this diagram, because it throws you off knowing that I might have lost these many marks. It's an 80-mark exam. So if you lose 20 already, we are marking your exam out of 60. And you know what that means. So it's really crucial and important to understand how to do these diagrams and to practice. And this question is an example that you can never predict how these diagrams look like, because this might be the only question I've seen so far that not only, but a few questions, one of the few questions where you've got two sets of inheritance going on, and hence warranting two factories in one diagram. You don't see this often, if at all, if you go through as many papers as you can, which is why I keep on emphasizing that there is no way you can cram how to do these questions. Just understand the concept and learn how to apply the concept, because you can never know how, the kind of diagram that you're going to end up with. So if you were doing this and you had not practiced, this would just look wrong. Like, where have you seen a diagram with these many classes and all these inheritances going on? You'd just be, even if you are right, you'd be like, you won't be confident unless you have really practiced and you know exactly what you're doing and why you're doing it. So that's why it's really important to practice. Otherwise, yeah, I do like this attempt. Any questions, comments before we move on to the next one?
Yeah, hello, sure, sir.
Mm-hmm.
So with this diagram, the only question that I have is with the client UI.
Mm-hmm.
So sometimes I don't find it easy to know which classes should I connect client UI to.
Mm.
So for e.g. Patient records,
Mm.
I used aggregation
Mm-hmm.
relationship.
Mm.
So I'm wondering in the exam, will they expect client UI? Will they expect me to include attributes inside of client UI?
Not necessarily, because the client is not always required. Sometimes they don't want it, sometimes they do want it. But it's a very good question because sometimes it becomes tricky knowing what do you connect to your client. But just to give you some hints in general, your container, the one that stores your records, is always going to be aggregation because if you think about your assignments, when you do your widget or your user interface, you're going to
Yeah.
define a list under private that stores your records. So always your container is always going to be aggregation. Your serialization is always going to be association because you don't need to store an instance of your writer or your reader. You define it, you use it, and that's it. There's no need to store this under private. So these normally just always become association. Actually, most of these classes should be association. All of them actually, except for your container, the one that you have to store under private. So in the general sense, the only classes that you normally put under private in your UI is your records, the actual thing that you need to store. Otherwise, for most of these, they can become association because you are not storing instances of those things. But the good thing, though, is even if you choose to put aggregation for your factory, you are not wrong because you can also define a factory that you can reuse as many times as you want. So these can also become aggregation. So I don't think there's much to worry about when it comes to the client, which is why you realize that sometimes, or in if not most times, they don't want you to put the client. Where you need to be careful is where you apply factory, because the idea behind factory is that your client must not know about concrete implementations. That's the only thing I think in this case you'd have to be careful about. In other words, we don't want, and you were right, to see your client knowing about these concrete implementations, because this is why you're using your factory. So you don't have these lines, and rightly so, you mustn't. So those would be some of the things that they want you to express and realize that you do understand that your client, by using factory, only knows about the factory, but not the concrete implementations of these types of classes. So there isn't much to worry about in terms of your client. So I think rather what I would say is if you're going to do a client, always put aggregation or composition rather. Yeah, maybe go with composition because if you're using pointers, your client must clean up. So you can use composition here if you want. Or aggregation, I don't think there are hard fast rules there. And association to almost all the classes. Just avoid concrete implementations if you have applied factory. That's generally how you would apply your relationships with the client. And I would also want to believe that most of the marks for this question would be what you've done here already. Even if you don't even put the client, I think you should be able to get 90% of the marks for that question. But the client is easy. Just put your aggregation or composition to your storage and association to everything else, and avoid linking to concrete implementations if you've put factory.
Oh, okay, I get you. Thanks.
Yeah, right. So yeah, very good attempts. I think this shows that you've really understood the concepts that we are always applying, and you've applied them very well. Now, the next question for this paper, 1.2, was regular expressions. The container code takes the following formats. Initial B or C character to indicate whether the container is a box or a cylinder. A 3-character serial number containing digits and uppercase and lowercase characters, right? A final character that matches the initial B or C character. Write the regular expression in quotes. Now here, I like that they do specify that it should be in quotes so that if you've got any backslashes, you then escape them. Sometimes they don't. That can be used to check that a container code meets the required criteria. An example of a valid code is BX, da, 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 da. Ensure that you use escape characters correctly. So they also emphasized here that you escape your characters correctly. So the initial B or C character to indicate whether the container is a box or a cylinder. Yeah, you're right. Just going A or B, you really went with A or B. But a general way of doing that is just to go square bracket A, B, because a square bracket is A or B. That's what it means. So anything that goes in a square bracket is or, because a square bracket matches only one character. So you're right to go A or B. You can also go with A, B in square brackets. Then you went with a 3-character serial number containing digits, uppercase, and lowercase. So here you went with a digit after your initial character. So remember your 3-character serial number here does not always start with a digit, but it contains digits, upper and lowercase characters, which means it can be like this. It can be B, C, X, 0, right? And the final character must always match the first one. But in terms of this part here, it can be in any order. There's no specific order here that says it has to be a digit, then uppercase, and then lowercase. No, it just contains, which means anything made up of those 3 items is correct. So in this case, you can have like a serial number that looks like B, then 222B. That's still fine because it does contain digits. So it doesn't have to be 1 digit or 1 uppercase character or lowercase, and it doesn't have to be all of them. So in this case, your assumption was I'm going to have a digit and then an uppercase character and then a lowercase character. That's where you sort of like misinterpreted the question. So this whole part can simply just be a digit, uppercase, or lowercase, like that. But this has to happen 3 times, like that. So it can be any of these, but 3 times. So you can have 3 digits, you can have a digit, uppercase, lowercase, but this, whatever this is, it appears 3 times, and that covers this section. And then your final must match your initial. So actually, you are right. I was wrong here because you would have to use a bracket. So if you're gonna have to do a back reference, this means match group number 1. Group number 1 is the first bracket that you use, and you used this bracket here and went with A, B. So if you had done it like this, you'd have to put this in brackets. But again, this was actually okay to just put brackets and go A or B, and this becomes your group number 1. So that was actually fine. So yeah, this part was right. The only part which was a bit wrong is this one here, because it assumes that it has to be a digit, uppercase and lowercase, whereas it can be any 3 as long as they are a digit or an uppercase or a lowercase character. That's the only part you would have had to correct, this part. Right.
Oh,
So
okay. I see.
you did that, but the question does not only want you to do the regular expression, because it also says an example. Oh, no, sorry. No, don't know about that. No, I take that back. Okay, yeah, that's fine. That's all. That's all. Okay, any questions here? Anyone?
Hi, Edmund.
Hi.
Yes, I've got a question here. I think I'm
Mhm.
missing something.
Yeah.
Because it says a final character. I mean, the last point here, it says a final character that matches the initial B or C.
Yes.
How do we, I've forgotten, how do we factor that?
Yes. So that's quite a big reference. So what you do here is you use a group, right? Whenever you do a regular expression and you use brackets, it creates groups. So by going, if let's say we write this regular expression and we just go A or B, then our three characters, a digit, A to Z, A to Z, right? Like that, which can be repeated 3 times. Now, that's fine. Now, this one here must match whatever has been provided here, right? So what you need to do is you use a bracket to reference a part of your regular expression if you want to reference it again somewhere else, right? So what you do is, because you want to reference this part, because whatever this is, it must match whatever this is. So you put a bracket around it like this. When you put a bracket, your regular expression is going to allocate this as group number 1. Let's say for some reason you put a bracket again here, here. Your regular expression is going to allocate this as group number 2. Let me write this correctly, as group number 2. Let's say you put up a bracket again. Let's say if it's a longer regular expression, your regular expression is going to allocate another group number to those brackets. So all these brackets are allocated group numbers in order. Group number 0 is always the whole match, even if you don't have brackets. That's group number 0. When you include a bracket, the first bracket that you include is going to be referred to as group number 1. So when you then want to say this must match this, you simply say this must be group number 1, which is this. So to refer to a group, you just use a backslash and the group number. So you go \1. If we wanted this to be exactly this, whatever this is, like the final character must be, well, we cannot really, it cannot match because these are 3 characters. But if you wanted to reference any other group within our regular expression, we just put the group number here. So this means whatever this is must be group number 1, whatever is in group number 1, which is whatever is in this group here, which is our group number 1. So that's why you see these brackets here that captures this group and allocates 1 to it. So anyway, in your regular expression, when you go \1, it's referring to this. So that's how you then make sure that your final character is the same as your initial character. It's because of this \1. Obviously, because this is going in quotes, every backslash must be escaped. So you put 2 of them here, and also here you put 2 of them. I don't know if that's clear.
Yes, it's clear. Thanks.
Perfect. Right. So yeah, this is also a common thing that you see in regular expressions where you do capturing groups. But for now, that's the only reason to use capturing groups. We also use brackets sometimes when you do ranges, like where you go 2000 to 2020, when I do a regular expression for this range, you may end up using brackets. I think there's plenty of examples you can play with for these types of examples. All right. 1.3 then said an input mask, okay, let me say that again. If an input mask were to be used for the input widget in the GUI, what string would be used to ensure valid values for the code required in 1.2? So it's the same regular expression, the same validation, but if we were going to use an input mask for this, what input mask would you create? If you go to the official Qt documentation and you just search for Q line edit and you search for input mask, you will see this table here that shows you input mask characters and what they represent. So in this case, that's how you do an input mask. A represents a character of any of the letter category required, such as A to Z, A to Z. Now, an input mask is used to control user input. Like, let's say if you've gone to websites that require you to enter your ID number, and you try and type anything that's not a number, and it will just not type because it wants a number. That's an example of an input mask. Or if you're trying to, like in your banking application where it requires an amount, you realize that if you try and type anything that's not a number, it doesn't take the input. It just won't work. It just doesn't take anything that's not a number. You have to press a number to type in there. Those are input masks because it masks the input. It creates like a template that says this is the only input you can type in this field. That's a mask. So it prevents you from typing a generally or an obviously wrong input. So an input mask is not as strict as a regular expression because it's just there to control your input to make sure that it follows the right format. Like you want to type in a date, so you can say these four spaces are for a number. Here we must put a backslash, and then here, and so forth and so forth. So that's an input mask. And these are the characters that you used for making an input mask. So A represents anything alphabetic, any character, alphabetic A to Z, lowercase or uppercase. Now, lowercase is usually the inverse of the uppercase. So if lowercase is an inverse of whether or not it's required or not for all these characters. So A uppercase means it's a required character. Lowercase means it's not required. Same thing, right? So A just represents your A to Z. N is for numbers, right? It's for alphanumeric. So it can be A to Z and a number. So the only ones you need to really remember are just A for alphabetic, N for alphanumeric, X for blanks, 9 for numbers, D for non-zero digits. Those are the most basic ones that you need to remember that we use for the most part. And now if you remember these ones, A means alphabetic, required, lowercase a, not required. N means alphanumeric, required, lowercase, not required. 9 means number, required. 0 means number, not required, or optional. D means non-zero digits. Lowercase d means not required. So that's permitted but not required. So these are the most common ones that we use for input masks. Now, on top of these, we also have to switch between lowercase or uppercase, right? And for those, you use these switches here. So if you use this right angular bracket here, you are saying everything that follows this is uppercase. And if you go this, it means everything that follows this is lowercase. And this means switch off case conversion. We'll do an example now, right? And then this terminates the input mask and sets blank character. See, this is very important. So the other ones that we normally just use are these two here for uppercase, lowercase. Sometimes in this one, if you want to switch between the two, I think that's basically what you would use for an input mask. Now let's talk about the previous question that we did. The first one is a character B or C. Now for an input mask, you don't have the privilege of going B or C. You just go A. It's an alphabetic character, right? Then the next three, we said it's number, lowercase or uppercase, if you remember, right? Which is these three: number, uppercase, lowercase, right? That's alphanumeric, pretty much. For this, if it's an input mask, that is just your N, but it's three of them. So you go N, N, N for 3. That's it. And then we said the final character must match the first one. What is it? It's an alphabetic character. So I just put A again. That's an input mask. So you can see it's not really very strict, because you can still type X here or D or E. You can still do that. And you can still put, for this is fine because, well, in this case, likely it matches what the regular expression requires. But this and this may not even match. You can put B here and then C here, and it won't complain because it's just a mask that says this is the format. So this would be your input mask. And again, it's not as strict as a regular expression. It's just there to control user input. So you may use a combination of both to just remove obviously wrong input, like where somebody's trying to type where a number is required, So that's where you can use an input mask, or to just make sure that your date format is in the right format to, and avoid obviously wrong capturing or data entry issues. Okay, but that's basically an input mask. So it takes some time to just remember what meta characters or mask characters you use and what they represent. It's not really a lot. It's just A, N, X, 9, and D. That's it. So you can remember those. Or since your exam is open book, you can just print this and keep it somewhere. All right, so that's an input mask. All right, so that was the first question for your 2024 attempt. I think, is there a question coming through or is it me? Okay, no question.
Yes, can I ask a question?
Yes, please.
I have a question.
Mm-hmm.
On the last question that we're doing now, the input masks.
Yes.
If I were to put 1A and curly brackets with 3 inside it, that's wrong.
Yes, because
is that wrong?
Yeah, so when doing an input mask, forget about regular expressions and repetition. A curly bracket, when doing an input mask, has a different meaning altogether. It's reserved. You don't touch those ones. It doesn't mean repetition. So you don't have the privilege of saying one. So things like one or more, or at least 5, or at least 3, those ones you cannot really do with an input mask. That's why it's like very, very general. So if you've got validation requirements where you have to use repetition, like 10 or 3 to 10, for an input mask, you have to repeat that 10 times because there's no repetition that says do this for this number of times. So you wouldn't be able to do that.
Okay,
Yeah.
thank you.
Yeah. Cool, good questions. All right, so that was the 2024 question 1 paper. Hoping you're going to finish it off so that we can talk about everything in there. You went to 2023 November and you did question 1 again. So this one says, a large store currently sells only books and magazines, although this may well be expanded into other items at some future point. While both books and magazines have a name, we also want to know the name of the book. Let me do this. Right. So while books and magazines have a name, we also want to know the name of the book publisher and the magazine frequency. A master list of all books and items should be kept, which should all have the functionality of a queue list. Okay. The client then contains an instance of this list, or in this case, they just said it there. I think we've just talked about this. But yeah, your client will always have an instance of the list, which can be accessed by several functions in the client. So this already is talking about that aggregation question that you discussed earlier. Even if they had not said it, you would still do it. Generally, that's how you would do your client. It would have aggregation with your container. And that's a very small diagram because we don't have a lot of classes here involved. But we do know that we've got a store that stores books and magazines, and they may be expanded to other items at some future point. So again, so are these classes, while both books and magazines have a name that gives it away, these are classes because they do have a name. We also want to know the name of the book publisher and the magazine frequency. Now they've given you attributes that are specific to each class. So for books, you want the publisher. For magazines, you want the frequency. So they've given you attributes that go into the so in this case, they only talked about books and magazines, right? Only. And they said both have a name, but books then have a publisher and magazines do have a frequency. Now, what they didn't do in this case is make it obvious, like these are all the classes that we have and this is where the inheritance is happening. They sort of like gave you the subclasses only. and you had to then see that you need a base class. And we'll see as we go through your attempt. The question then says, considering the scenario given above, draw a partial UML class diagram that captures the scenario. You should include the necessary classes, attributes, relationships. In the scenario, class constructors, functions, access specified are not required. So you see, this is where they don't need your constructors or member access specified. Just your attributes, just list them. However, you should ensure that you include all the data members and member functions that show how data will be moved around the application. You should include the client or the GUI class, right? So let's go straight into your attempt here for the sake of time. So the first thing that I like is that you were given a book and a magazine, and you knew that these have to inherit from somewhere. This class was not given in the question. They simply said we've got books and magazines. And you were able to realize that, okay, if I've got books and magazines that are classes, this one is a publisher, this one is a frequency. What they didn't require, though you put these access specifiers. So they were not required, but still that's fine to include them. But then, you went ahead and then you said they both have to inherit from a base class, which would then have a name. So perfect. Again, this was not really required. So that's the first thing that you did right, just knowing that we have to introduce another class which is going to act as our base class for books and magazines, and they both inherit from there. We do know that these are plurals. Yeah, we've got a list of all books and items that should be kept. So you went ahead and did your list of books, inheriting from a queue list of type item, and that's your book list, and you've got your composition. Again, that's perfect. That's fine. Then what else was required here? Then they said, now you do your client, which should have a list inside. So inside your client, now, if you have books and items as your class, this is what we should see here. That's your list, not this. Because then if you do this, and then you have another list, then where are you using this? So you would want to then, in here, use your actual list. So you would have your books and items here. Books and items inside your client GUI, and you can have your aggregation there. That's all they talked about. So your diagram is fine, but again, as a matter of habit, I think you should always try and cater for things like factory, even though they don't talk about it. It's just one of those things you should always include. So to play it safe, always introduce factory where there's inheritance, unless otherwise told so. Put it there because it helps to have that design pattern. The next thing we didn't talk about is abstract classes, right? Should your base class be abstract or not? In this case, you can have item. Can you have an item that is not any type, that is just an item with a name and you don't know what it is? That's the question you have to ask yourself before you decide whether or not this can be abstract or not, right? Is it possible to have an item? It's not a book, it's not a magazine. We don't know what it is, but it's an item. Like a generic item that just has a name. So that's subjective. It depends on how you defend it. But generally speaking, your diagram is fine. I think you've got the idea of how to draw these diagrams. It makes sense. I think I'm happy with it. Then the next question now for this question says, consider the two partial UML class diagrams depicted below. So you've got item here and item there. Explain the difference, what the difference is between them and the effect this will have on the rest of the application when dealing with books and magazines. Obviously, the difference we see here is that and that. That is what you have to explain. And what its effect is going to be when dealing with subclasses. So in other words, this question is saying, what is the effect of, what's the difference between having a private and a protected member variable when it comes to subclasses? How are they affected by the two? It was just a general question. I don't think it's specific to any topic. It's just a general question. And then you say the difference is that the attribute name in the first class is private and can only be accessed within the class item, the item class, whereas in the second class, name is protected and can be accessed by both subclasses, book and magazine. Yeah, that's it. That's it. Happy with that. That's exactly what it means. Should the item class be abstract? Not that marks are only allocated for explaining your reasoning. For me, this question has no right answer. It can be yes, it can be no. It depends on your justification of whether it can be abstract or not, which is why earlier I said it's subjective. So you can say yes, it can be abstract because an item cannot exist unless its type is known, right? That's the only reason it would be abstract. It means we cannot just have an instance of an item and we don't know what type it is, right? It may not be abstract, again, because you can have an item that only has a name and no other attributes. So in that instance, you just want to make a concrete class for the item class. So it all depends on how you explain. I think the most important thing is to understand what abstract means and why you may want or may not want to make something abstract. So making something abstract means it doesn't make sense to have an instance of that class, and therefore it must never be possible to make an instance of that class. Not making it abstract or making it concrete means that class can exist as an instance. Why depends on the scenario, and in some cases, there's no right or wrong. It just depends on the reasoning behind the design. Whereas in some instances, it may be obvious. For example, where you've got a bank account, it can be check or savings. It cannot just be an account. And in that case, you can say, no, we cannot have an account which is not an account. It doesn't make sense. So there are certain instances where it's clear that your class has to be abstract. But in this case, this was an open question that simply required you to explain in this context what an abstract class is in relation to the item, using item class as an example. So again, it could be abstract. If you say it's abstract, you are simply explaining why you cannot have an item instance. If you say, no, it doesn't need to be abstract, you are simply explaining why it makes sense to have an item class to be able to make item instances. In both cases, you can still get 3 marks. So that's the beauty of a question like 1.3. There's no right or wrong answer there. It's all in your justification and explanation, proving that you do understand what an abstract class is. 1.4 for this question, it was decided to use effect method pattern when creating items for the store list. The following EMOS diagram was provided. If this representation is correct, explain in detail how the creation of items is implemented, filling in details that may be missing from the YAML class diagram provided. If this representation is not correct, redraw the diagram. Right. Now, this is not an open, this is not the same one as before, where both cases you can be right. There's one right question, there's one right way and one wrong way. So, but they do say if you think it's wrong, fix it. If you think it's right, do this. But in those cases, one of them is wrong. Like it's not like you can be right in both cases. No. Now the question is this right? I think it's obviously what? Is it? You skipped this question. I don't know why you skipped it. You skipped it. So maybe we should skip it too. Where's the question? Oh, what did I do? I don't know, it's gone. I lost it somewhere. Let me find it. But anyway, what do you think of that diagram? Do you think it's right? Do you think it's wrong? I don't know what I did, but for some reason it's gone from my screen here. I don't know what I clicked. It's really, really gone. Yeah, I don't know, and I cannot even undo. for some reason. It won't allow me to do that. But anyway, yeah, what do you think? Or do you think it was right? Come on. Where did it go? I lost it somewhere. I actually lost it. Yeah, it's gone. I don't know what happened, but I lost that. Anyway, we are running out of time. But what we do have though is item here with your creates, and then you've got your, I think you've got your factory here, if I'm not mistaken, something like that. And then it says, is it right or wrong? What do you think? Do you think it's right? Do you think it's wrong? If you know factory, what do you make of that question? I'm gonna try and find it now quickly from the paper. What do you make of it? Obviously right or obviously wrong. But either way, oh yeah, sorry, it's that's not your factory. This one is the client. So you've got item here, then you've got creates, and then you've got your client here. Right or wrong? In terms of factory, who wants to give this a try quickly? We've got a few more minutes to go. If this is not obvious to you, I'm worried. I'm really worried.
Can I have a try, sir?
Please go for it.
I think it's wrong.
It's wrong. Okay. Yeah, obvious.
I don't see a factory.
Obvious. If we are not yet on the obviously wrong or obviously correct part, it means we've got a long way to go. Because at this stage, things should start to become obvious for you. Like you look at it like, hi, obviously this is wrong. If you're confused, I'm concerned. It's wrong, you're right. Yeah, I mean, factory, we know factory. Factory, when does a client create items? When? It doesn't happen, right? We've just discussed factory in the previous questions that we were looking at. And I think we talked in detail on this question here, and I said your client can never know about concrete implementations. Your client only knows about the factory, which is clearly missing totally from that diagram. It's a client and a class, and they said, is this factory? There's no two ways about that. There's no thinking required there. It should just be wrong because our client and a class cannot make up factory. Factory is made up of your item, your factory, and then your client uses your factory. So if you want to do factory, you're going to have an item, you're going to have your factory, not knowing if they wanted you to do inheritance, but then you've got your magazine, you've got your books. Your factory is the one that uses your item and is the one that creates your items, right? Creates. And then your client is the one that uses your factory. That's it. Assuming that we don't introduce inheritance, let's say it was just being done with the item class only, then your factory is the one that is responsible for creating your item. And then your client uses your factory, right? That's factory method. So factory uses item, creates item, or if it's got inheritance, then this goes on inheritance, and then your client uses your factory. That's basically how you would fix that. So yeah, get used to factory. It's not very complicated. I think in almost all the diagrams that you do, one way or the other, you do apply factory like you did here. You've got an infection with types. Factory uses that and it creates the types. Your client uses the factory. So this here is again, same question, just asked in a different way. Now, for the sake of finishing all these questions today, let's look at the last question for this paper, which question one, which was regular expression. The plan is to include an item code for each item that adheres to the following format. Starts with either BK for a book or MG for a magazine. I'm going to do this right now and just take it as we go. Any questions, please jump in. So you go with, starts with that, this or that, perfect. A number in the range, those ones now are the tricky ones. That takes up 3 positions in the code. Now remember, this is tricky because a number in the range 0 to 399, this does not cater for 399. I cannot have 399 here. Because here you went with oh, sorry, you actually might be right. You went with the first one can be 0, 1, or 2. Yeah, let's look at it. That actually makes sense. So you said the first one can be 0, 1, or 2, then the last two can be any 2 digits. That's fine. You did this very well. Okay, I thought you fell into the obvious trap. So what I like here is that you restrict the first digit from 0 to 3 only, because the first digit can only be between 0 and 3. And that's what you did here, 0, 1, 2, 3 for the first digit. And for the other 2 digits, those can go up to 9, from 0 to 9. And that sorts out your range. So well done on picking that up. And underscore, fine. 1 or 2 lowercase alphabetic characters where the final character should not be a vowel. 1 or 2 lowercase where the final character should not be a vowel. Now, it's 1 or 2, right? So here you already catered for 1 to 2. Whereas the final character is for these 2 here. So you've got 1 here. You've got 1 character, 2 here. This one here is the one that should not be a vowel. Whereas here you went with 2, A to Z, and then a final character that cannot be a vowel. So now that makes them 3. There should be no other characters before or after this code. This is simply your starts with, ends with, which is fine. So I'm happy with that. A Q regular expression will be used to write the regular expression that goes here. That's fine. So the only part that I'm having, yeah, so is this part here. So you've got 2 characters, and of those 2, the final one, right? So you've got 1 or 2, where the final one, which means of the 2. So your idea is right. So you'd have gone with A to Z for the first one. Then this here would have to go here as the second one. And then know this. I don't know if I'm making sense. So instead of putting 2 of them here and then having a final one, which is not a vowel, you would simply have 1 character, which is A to Z, and then this becomes your second character, which is not a vowel. And you went with not any of these. That's the only part that I would correct. But otherwise, the idea was perfectly executed, especially this part. I like this. All right, write down, okay, 1.5.2, which would be better to use to validate the code when a user enters it on the GUI, a regular expression, or an input mask. Use an example from the required code format to show why you say so. The mark is only awarded for the explanation. Why would you use a regular expression versus an input mask? You already have the regular expression. Again, an input mask, you said it's less strict. So what this question is saying is give us an input mask for this and just show us, because that would then show that you would rather use a regular expression, because an input mask cannot do things like this. Like in this case where you want to start with MK or BK, what are you going to do? You're going to have what? AA, that's all. That's all you can do. You cannot go BK or MG. It's just 2 alphabetic characters, all lowercase. Then you've got 3 numbers, right? 3 numbers, which means you're going to go with what? 999, right? And then you've got 2 lowercase characters. Again, so you can see it does not, it won't allow you to enforce more strict validation, like only allowing for these specific characters or only allowing numbers within a given range. Is it 99 or DD? Sorry, you want, yeah, 99. That's fine. Yeah, that's fine. So for this question, you would simply provide an input mask for your first 2 characters, your 3 numbers, and your last 2 characters, and you'd, by doing this, show that you'd rather use a regular expression, because an input mask cannot be used for more strict validation. And that's your question 1. And it's only 1 mark, so yeah, it's not like you are losing much, but that's how you would do that question. All right. I think for those who are not practicing, this is what you should be doing. Let's attempt questions. Let's practice, because that way you know exactly what you need to work on, what you need to fix. And we'll keep on discussing this question. So we've been doing a lot of question ones, I think, sometimes question two, but it's high time you start moving on to MV programming, threads, XML. There's a lot that you need to look at, reflection, all of that. So let's try and attempt a full paper. Try and attempt a full paper and see how you go, because that's how you then figure out which topics you still have to worry about or work on, because you've got about 8 topics to do and to do them very well. But I hope this is helping to understand that you've got a lot of work to do. And today we only covered 2 topics, UML diagrams and regular expressions. And you can see how much effort can go into just doing question 1, right? Out of all the questions that you have to do for this paper. And if you don't do question 1 very well, you may lose probably 30% or 40% of the exam just from question 1. So that's why it's really important to prepare. You want to be able to do this and be comfortable that you have covered your UML diagrams, you are comfortable, you've covered your regular expressions, go to reflection, MV, threads, XML. What else? I mean, there's a lot. So yeah, let's design patterns, factory, singleton, memento, all